We're doing 6.3, and that way we can spend time tomorrow doing 6.3, okay? So, all right. So just jump to 6.3 on your notes real quick, and we'll start over here on this side of the board. So you guys look over here. So, all right, so look over here. What's the integral of x squared?
X half the over 3.
So it's x to the third over 3. Then what do we write? Plus c. What happened to this dx?
Disappears.
Disappears? What happened to that?
It disappears.
Disappears. And you guys asked me about it. When we first learned it, you're like, what happens to those? And I said they disappeared. You guys have now used to that? It doesn't bother you anymore? That was chapter 4, right? You guys are going to learn where they come from. So you guys are going to learn that where this dx comes from today. You're going to learn where they come from in the separation of variables. But these guys just disappear. And we'll talk about that in the 6.3. Finally get to learn where they came from. But you're going to run into these integrals today. Just a quick reminder. So if you have 1 over x minus 1, what is the integral of 1 over x minus 1? What is this integral? This is ln. So this is ln of x minus 1. This is not ln because it's squared. So we're going to bring that up. -2. Now if you guys have a binomial to a power, you could do substitution will always work for us. But we're going to learn if we have just a binomial, you guys can just add 1 to the power and divide by that number. All right, so if you just have a binomial to a power, you can just go, I want to add that 1. Since the derivative inside that binomial is just 1, we're allowed to do this. So x minus 1 to the -1 over -1 plus c. And that cleans up to be -1 over x minus 1 plus c. We're allowed to do this with any binomial. So if I have like integral of, x minus 1 or x, it could be x minus 10 to the 8th dx. I'm allowed to do x minus 10 to the 9 over 9 plus c. I could just add 1. That's because the derivative of the inside is just 1. If this was a 2 here, then I would have to adjust for the 2. The derivative of the inside would be 2, so I'd have to also divide by 2. That's a shortcut with binomials. Now we talked about this very briefly in chapter 4, but like when I taught my IBHL class, we used to have a whole section on that. That was just a whole thing we talked about. So we'll discuss that later, but I just want to show you that it can be done by substitution, okay? All right, so we're going to separate the variables here, and this is what this is all about. You guys are given a derivative. All right, this is a derivative equation. So dy dx equals 10x to the 4th over y. You're given the derivative. Now, we want to find the original equation. The original equation is y equals something, all right? And they're giving us something. You guys have no idea what this is for yet. We'll talk about that soon. This is just some point to you guys, and we'll explain the significance of that value. The directions say, find the particular solution, y equals f of x. I'll tell you what all that means. Now you're given a derivative. Do you see how your derivative has an x and y mixed? See how there's x's and y's in our derivative? The derivative still stands for what? What's it find? Slope of the tangent line. It still finds the slope of the tangent line. That hasn't changed. But it has an x and y mix. You guys cannot take an integral when x and y's are mixed. I can't just take an integral of 10x to the 4th over y with a single integral. All right, it requires double integrals and stuff, which is a class above us. So what we have to do is separate the variables. Now, separate the variable means all the y's, since your dy is on top, all your y's have to go to the left. And all your x's have to go to the right. Now this y, since he's on the bottom, how do I move this y to the other side? Well, he's dividing by y, so I'd multiply both sides by y. So on the left side, I would get y dy. So move that y over to the left. This dx, I'm going to move it to the right with a 10x to the 4th. So I'm going to get 10x to the 4th dx. This is why it's called separation of variables. All your y's go to the left, all your x's go to the right. We're separating them. So all your x's and y's are separated. If you can't tell the difference between an x and a y, and you don't separate them, you get 0 points on the problem. On the AP test, this is worth 5 points. There's nothing else that we learn that's worth 5 points. for an A/B student. So this is the most. Just to pass the test, you start with 0. You're trying to earn around 36 points to get a 3, around 54 to get a 4, and you start with 0. This is 5 points already. If we can learn how to do this. If you can't tell the difference between X and Y, you get no points. So go 0 out of 5, and you're done. All right? So by separating them, you've earned a point. So you notice that it's like you just cross-multiplied. Very equivalent to cross-multiplying there. But you're wise, and you got to be able to know if it's on the bottom, it goes to the top. It's on the bottom here, it goes to the top. So now I've separated, and once we separate it, we take an integral of both sides. So take an integral of both sides. Do you now notice what you've solved before over there on the right side? Now you see where the dx's came from. What you guys were doing in the past is you guys were just practicing one side of an equation. In chapter 4, we're just going, hey, what's the integral of x squared dx? There was a left side that you guys never saw. But you guys are practicing a skill. That's what we're trying to teach you. Integration is, hey, let's practice a skill. Now that you've practiced a skill for chapter 4 and 5, now you're going to get the real stuff. Hey, what is this? Why did you practice this whole time? So you actually can see there's really an integral on both sides. To see a full equation. To have an equation, we need a left and we need a right. So we're going to take the integral of the y side and the x side. So this side is y dy. So you just take the integral like you would x's, it's just the y's. So what's the integral of y? y2 over 2. Now what do we normally write? Plus c. Don't. Well, we'll talk about that. Equals. What's the integral of 10x to the 4th? 2x to the 5th, all right? It's 10x to the 5th over 5, but the 5 and 10 make a 2. So everyone agree, 2x to the 5th. This time we do write the plus c. So let's have this discussion. We're supposed to write a plus c on both sides, right? Did we take an integral of both sides? Let's discuss why. I'm just going to write it up here, then I'm going to erase it. We took an integral of the left side, just watch, and it was a plus c. We took an integral of the right side. It was a plus c. But there were different c's. This one could have been c1 and this one could have been c2. But our goal eventually is going to be get y by itself. So we could send this c1 over and subtract it over here and just combine them. What c is just some random constant. So we can combine these guys and just make them some random c. So instead of doing all this extra work, we go, all right, let's not even put it over here. Let's just put a random c on the right side. The reason why we just choose to put over here, because we want to solve for y. So we want to put everything away from y. All right, so we just call a random constant. So because we have 2 of them, they're just going to combine anyways. Does that make sense? Because we just have some random number jumping around somewhere. So we just put it over here. All right? Now, you have earned 3 points out of 5. What were the second and third points? When you took an integral of this side, point. Integral of this side, a point. Separation was the first point, so we've earned 3 points. All right, here's your last 2 points. You must find c, and you must be able to solve for y. Here's what told you to solve for y. Find the particular solution, y equals f of x. That is saying we want you to solve for y. That's their way of saying get y by itself. All right, so I don't like this 2 on the bottom, so I multiply by 2. If I multiply by 2, what happens to that c? It just becomes another c, but typically I'll just call it, whenever I change my c, I'll change its subscript. So I'll call it c1. You could just call it, AP will usually just call it a c again. Sometimes they might even call it k, change its letter. Usually we use c or k for a constant sound, for constant. But I'll just call it c1, all right? So it's just a new constant. And the reason why I like to change it is because you might be in a group with a friend and they found c here and you found c here, and you'll get a different value, but in the end we'll have the same answer. All right, you'll see what I mean when we get to some homework practice. All right, now we still have to find c, we have to solve for y. So I'm going to find c now. Now I used to have my students find c right here, but I started, this seemed to help. My scores got much higher when I had them find it off to the side. So let's go ahead and find c over here to the side. And how do I find it? That's what this point is. This is a point they're telling us that works in the original equation. That point is saying, hey, when I plug 1 into for x, y equals -8. So they're telling me a point that works in my equation, so that's going to help me find c. My students for 30 years have called it a c finder. Gee, why do you think they call it a c finder? Because it finds c's. So they refer to it as c finder. So I may say, hey, look, that's our c finder, and you guys can call it that all year if you want to. It has other uses, but I'm fine with us calling it a c finder here. So we plug in -8 for y, because that's what this says. Y equals -8 when x is 1. All right, so I plug in -8. What's -8 squared? 64. And I plug in 1 for x, so I get 4 plus c, 1. What is c1? 60. Oh, there'll be somebody on the test that puts 16. What are they doing? Doing bad math, right? Because the opposite of plus is subtract, not divide, right? Some people they'll just divide the 4. That's plus. So C1 is 60. So we need to put it in here. As soon as you find it and put it here, I will give you your 4th out of 5 points. So we'll AP. They'll go, you've earned 4 out of 5. That's a nice B minus. So how do you get the 5th point? What do I still have to do? I have to solve for y. Because the directions say, find the particular solution y equals. If you don't find c, that's called a general solution. You guys know what that is? That's all the solutions to this problem without a c known. If I don't give you a c finder, then you find the general solution. I used to have a homework question in my notes saying, hey, let's find a general solution. I did that for about 15 years. AP has never asked for a general solution. I just threw it out of my notes going, all right, why am I making you find a general and they never do? So I can always talk about it. A general solution means we didn't find C, all right? So this is a particular solution. So we got to solve for y. So how to get y by itself? Square root. And when you guys take a square root, what do you guys have to write? You're supposed to write plus or minus, but don't. You're supposed to, but don't for a second. So let's write the radical. But you're supposed to write plus or minus. But actually, when you guys write plus or minus, you're actually writing 2 different solutions. One of them is actually true, and the other one's not true in this particular problem. Because we're writing the particular solution. The solution you're writing is the one that works for that point. The only fact you know is that point works. So this one says when I plug in 1, I get -8. So let's go ahead and plug in 1. Plug in 1, I get 4 plus 60 is 64. The square root of 64 is 8. Oh, I'm supposed to get -8. The negative stays. So the key is, whenever you guys take the square root of both sides, it's supposed to be plus or minus. The C finder will tell you which one stays. If your y value is negative, the negative stays. If the y value is positive, then the positive stays. That's how you know. I will have these in the homework practice. We'll have one of each to see if we can get this straight. So we'll do 2 more of these, and we'll practice this, and I'll talk about it in detail when we have a little bit more time. We'll do these again. But so when I get to here, I go, is it plus or minus? Then I go, well, that point has to be true. So I plug in 1, I get, well, square root of 64 is positive 8. Oh, I need a -8. The negative sign has to stay. So the C finder has to be true, because they told me that's the only thing we know is true. And so that's how you know which one is correct. And that's your particular solution. That's the one solution that works. Do you guys know when you guys did the slope fields on Friday? That was the solution, that was the general solution. That was all the solutions, no matter what C was. That's general solutions, all right? I'm gonna have to erase this to do the next one. Are we on board? Can I erase? Anyone have a question? All right, now to move things side to side isn't always the easiest thing to do. The only way we can move things is multiplication and division. We just can't move things over the way this one's written. So like when I have a dy dx, I either have to have like a fraction here, something over something, or I gotta have a product. I gotta have something I can multiply and divide by. So the only way I can do this is to factor out. So I put one like these on the BC test this year, and I had probably 4 of my 40 that I stared at. Even though we did in the homework, they stared at one. Yeah, I'm not sure what to do first here. So what you have to do here, and this has been an AP test question, you got to factor out the 12x cubed. You have to turn your derivative into a product so I can separate. I can't separate if it's not a product or a quotient. All right? So pull out whatever you can. You may not be able to pull out the full 12x cubed like it did, but in this case I can. All right, now if we separate, the dy and dx have to be on top. So since your dy is on top, your y's are going to go to the left. So what comes over here with the dy? Y minus 1, where's it go? Top or bottom? It's on top over here, right? So how do I move it over? It's going to divide. So he's going to go down here to the bottom. Right? It goes from top to bottom. I mean, how do you move something from one side to the other? If I have 2x equals 8, if I'm timesing 2, I divide by 2. If I'm dividing, I times, right? Do the opposite. All right, what about on the right side? That dx is going to go over there. The 12x cubed is already over there. And the dx is going to multiply. This is like our little math 1 here, right? A little basic math. Just opposite of multiplying is divide. Opposite of divide is multiply. So we separate variables. Do you guys agree? Left side are y's, right side are x's? We get 1 point. Yay, we earned a point. So now we're going to take an integral of both sides. Now the left side is 1 over, you guys don't see it 1 over y minus 1, which is, you're saying ln right off the bat. That's ln, top straight at the bottom. So that's ln. All right, let me be clear here. AP loves ln. I'd say probably in the early 2000s to 80% of them separating variable are ln. That's a strong number. Pretty strong number. Lately, probably last some years, maybe till 2015, the last 10 years, they've been doing a different style. So, and I'll show you that style that's on the next page. All right, so ln, and then what's the integral of this one? 3x to the fourth, and then we put the plus c on this side. You could put on either side, but we want to solve for y. All right, as soon as you guys take an integral of both sides, you've earned 0.2 and 0.3. Now let me tell you the truth about the AP test. They make this worth whatever they have points left. Every problem has to be 9. So one year they made it only 4 because they only had 4 points to give. That's too little. Only one time I've seen 4. And one year I saw 7. That's too many. That was craziness. I don't know how they got 7 out of there. I don't even remember how they got 7. That's terrible. That was one, I mean, I've studied this test for 30 some years. I've read so many questions. 6 and 5 are the most common. 5 is by far. 6 is when they're hurting for a 6 point. I'll explain how they make up the 6 point here. The 6 point is just writing down C. They'll give you a point for writing it down and then a point for finding it. That's how you get 6. So some years get lucky. They're like, we need to come up with a 6 point for this. All right, you get a point for writing it down and then a point for finding it. So it's a free point. All right, so sometimes they're very nice, okay? All right, we got to find C. As soon as you take an integral, C is available to find, but I have one tip. My experience, if there's an ln on your left with the y, get rid of it before you find C. Man, there's so many math laws that you can run into problems if you find C earlier. It's a long discussion we don't have time for today. Should have been in trig, you talked about it. But since you can't take an ln of a negative number, you could run into so many things that could cause you grief. There was a parachute problem we did on the AP test that if you found your C early, it caused grief. Because I remember doing it, going, ooh, caused so many people grief. So you want to get rid of this first. So how do we get rid of ln? Base e to both sides. So we're going to e both sides. All right, now we got some more math rules to learn here. All right, what does e to the ln do? Cancels. Now, when this cancels, what are we left with over here? I don't need the absolute value anymore. That bugged me too. First time I did, I was like, do I just get rid of these absolute values? Well, they were there because of I can't take an ln of a negative number. Once I get rid of the ln, I don't need them. They were there because of the ln. So that's good news. I've studied AP. They always get rid of it. And I'm like, yes, good for me. All right, so y minus 1. All right, here's where I lose people. I can do 10 of these and I will lose some of you. Sad to say. I hope I don't lose anybody. So let's do some basic